Question 4. So we've got a graph here. The graph shows the blood glucose concentrations of 2 people over an 8-hour period after eating a meal. So let's have a look at these X and Y axes. We'll start off here. We've got blood glucose concentration, which links in to this part of the stem of the question. We've got time after eating a meal, which goes from 0 hours to 8 hours, which links in to this part of the stem of the question. And clearly we've got these 2 people as well, with and without diabetes. Looking at the graph, we can see we've got 2 curves that go up and down. There's certainly 2 lines that go up and down, and there's quite a difference between them. So all this information is likely to be needed to answer the questions. First question: describe changes in blood concentration for a person with diabetes. The person with diabetes is of course here, that bold line. How does it change over time? Quite straightforward. Let's start with blood glucose concentration. Increases in the first 2 hours, we could say. The first 2 hours. And then decreases. So I've basically described the changes, and I pick up 2 marks. So the next question is as follows. It's a calculate, so we're thinking higher order thinking now. Calculate the difference in blood glucose concentration between the person with diabetes and the person without diabetes 2 hours after eating the meal. So let's see if we can work out what's going on there. So we need to look at 2 hours after eating the meal. We've got a point on the graph here and a point on the graph here for those 2 people. My pen will respond. Come on, machine, don't let me down. Anyway, as you can see, we've got 100 as opposed to 350. There we go at last. So there's the difference. 350 take away 100, which I think we all know is 250. 250 milligrams per litre is the answer there. So if we come back to the question, we can just slot that answer in as 250. Okay, don't even have to remember putting the units. You get 2 marks for that. And of course, by writing your working, even if you make a simple arithmetic mistake, you'll still get at least 1 mark. So moving on, we have another couple of questions here. In which 2-hour period did the blood glucose concentration change the most for the person with diabetes? Put a cross in the box next to your answer. So I think that will be 0 to 2 hours. So let's just have a little look. Yes, 0 to 2 hours. That's where we see the biggest change in blood glucose concentration. So that's fairly straightforward for us there. So 0 to 2 hours. Name the organ that releases insulin to regulate blood glucose concentration. So this is a name question, factual recall. What releases insulin? Well, the organ is the pancreas that does that. Can you remember remember the target organ that insulin acts on? Hopefully you're thinking of the liver. Part C. Part C is a 6-mark question. Plant hormones affect the way plants grow. Explain how growth hormones cause phototropism and gravitropism. So rather than write the answer, what I'm going to do is explain the science behind this. So what do I have? Phototropism is something that's seen in shoots. So we've got shoots, and we know that those shoots are above ground, and they tend to want to bend towards the light. So the shoot will start off like so, and what will happen is the growth hormone will accumulate here on the shaded side of the plant. So this is in the shade, whereas this is in the light. What does the growth hormone do? Well, we could say that growth hormone is called auxin, using the key terms there. So auxin, what does it do in a shoot? It stimulates growth. Stimulates growth. And what that plant will do is it will bend towards the light. So we would need to say that it bends now towards the light, because we've got growth in this side of the plant. The cells get bigger. If we compare that to what happens in roots, we've got a somewhat different story. So in roots we've got gravitropism. So here's my root, and this time the auxin is accumulating on the underside, so gravity causes the auxin to sink to this side of the root. Rather than stimulating growth, it actually inhibits growth. So here we've got inhibits growth. At least it inhibits growth on this side. On the top side we've got stimulation, or rather we've got growth, not stimulation, but just ordinary growth. So this continues to grow, and with the growth on that side, the root will bend down into the earth. So that's how the hormone auxin behaves in shoots, causing it bending towards the light, phototropism, and how auxin operates in roots, causing it to bend down into the earth towards gravity. So an explanation of that and a helpful diagram will get you 6 marks.